Today's lesson is on the law of cosines, and you likely have seen the law of cosines, but we do amp it up a little bit in PreCalc. Now that you have some trigonometry background, there's some more things that can kind of happen that we introduce at this level. The first thing I'm going to do here, though, is do a quick review of our law of sines and do an example of that ambiguous case, because typically that's the one that everybody messes up with. Now, so let's look at this. We know that it's an angle side-side situation because we have an angle with two sides and you have that matching set. So I know that's that side across. That's going to be that swinging leg. I notice that this swinging leg is a 26, which is shorter than the other leg. So I do feel like there's going to be a second triangle. All right, I'm going to go pretty fast on this. There are additional tutorials on this if you need to watch more, but we're just reviewing from yesterday real quick. So I'm going to start off, I'm going to say that's 26 over the sine of 22 is equal to 32 over the sine of angle A. Now you can show as much or, well, I like to see this proportion at least, but then after that you can show as much or as little homework or work as you need to. I usually just type it in my calculator. So it's 32 times the sine of 22 and divide that by 26. All right, now because I'm looking for the angle, I'm going to do second sine on that to get the angle measurement. And I have an angle A of 27.5. I'm going to round to the tenths today. All right, so that's my angle A. And then once I have angle A, that's my second angle. So my third angle is just going to come from subtracting from 180. So I've got 180 minus the angle A, the 27.5, and then minus the 22, that was angle B, and I have 130.5 for angle C. Now that I have angle C, I could go find little c. I always go back to what was given, so I'm going to go back to my b's here to set up my law of sines. So I'm going to do 26 over the sine of 22 equals little c over the sine of 130.5. And then back to my calculator. I cross multiply the two parts that I know everything. So 26 times the sine of 130.5. And then divide it by the sine of 22. And my little c $52.8. All right, so that one we're just kind of plugging and chugging through your law of sines. It's really this second triangle scenario that we have to work a little bit on. So when I draw this, every single time I draw it with the given angle down here in the bottom left. So this is going to be angle B. And I sort of make this like an acute angle, and I try to draw this triangle so it looks like this every time. And then this right here is the triangle that I just found. Angle B was given to me, so I know that this was my side B, and I always put the other given side right here, which was A. But more importantly, what that's telling me is this is angle A right here for me, and this is angle C then. Now that's the triangle I've found, so now I have to find the scenario where this leg over here on the right did not swing out toward the right, but instead swing towards the left here. So swing, is that a word? I don't know. Okay, so I'm going to draw that leg over this way. And this red triangle is what I'm looking for now. So A is now over here. Recall that when you draw this, you've forced this into an isosceles triangle. So these two base angles right here are the same every single time. And that angle A I just found was right here, 27.5. So this one is 27.5 also. What I really want, though, is the angle right here. And so I'm going to do a 180 and subtract that 27.5 because those are supplementary right there. And so I have angle A is A prime 152.5. Now I'm going to come over here and start my list. I find these same three things in the same order, kind of the same way, as soon as I can get that A prime figured out. It's a 152.5 degrees. And then I need my angle C, which is up here, which is teeny tiny now. So I'm going to take 180 and subtract the new angle A that I have, so 152.5, but also subtract the 22 that was given, and I end up with an angle of 5.5. Feels really tiny, but oftentimes that little angle at the top ends up very small. And now what I'm going to do is go back to what was given. I'm back to 26 over the sine of 22. And I'm looking for little c prime. I'm looking for this length down here now. It's a lot shorter than it used to be. And I'm going to use my 5.5 degree angle to get to that. So 26 times the sine of 5.5, and take that and divide it by the sine of 22. And I have a little c prime measurement of 6.7. So this is all of the second triangle stuff. Kind of helps me in your homework if you tell me, oh, this is the work for the second triangle. And you can see I don't have a ton of work to show, just a little bit along with my picture and just well labeled so I can find everything. All right, so that was law of sines, the ambiguous case. It doesn't happen all the time. Remember, you're only going to be doing this ambiguous case if you're given angle side side and that there's going to be a second triangle. Remember to tell that there's a second triangle. This leg right here needs to be shorter than what this leg is, but not crazy short to where it doesn't create a triangle, because you're going to end up with an error in your calculator if that happens. All right, let's look at this scenario. I have, in this case, it's not an angle side side. It's actually going to be a side, side, side. Now, I normally will just turn you loose, say, go solve this one. But since I'm doing a video, I'm just going to go ahead and tell you, hey, this doesn't work. You don't have any angles. You can't get any matching set to set up a proportion. So when you're given a side, side, side scenario, that cannot be solved using the law of sines. And so that's where the law of cosines comes into play, which is what we're doing today. This may look familiar to you, the law of cosines. It's kind of a long formula, but it has some nice patterns that make it not too hard necessarily to remember. So you have your a squared right here. That's one of your legs. Here are your other two legs, minus 2 times the same two legs you were just using right here, always the same, times the cosine of the angle that is across from the side you're searching for. Now, don't get too caught up in the letters themselves. It's more about the pattern, because it depends on what's given to you on which one of these you want to use. So it could just as easily been written b squared equals, and then what that means is you'd have to have an a squared plus a c squared on this side, minus 2, and then again, it's the same two sides you were just using. So in this case, AC, cosine of the angle across from what you're looking for, which was the B. So it's going to be cosine of angle B. All right, could you write the third version, the one that starts off C squared? Why don't you go ahead and do that? All right, this is what I have. All right, let's keep moving. Because you've done the law of cosines before, I'm going to kind of jump into what's new with the law of cosines. Typically, we're going to use the law of cosines just to find one more piece of missing information, and then we're going to go back to our law of sines, because the law of sines is quicker for us. Now, when you're finding the missing angle, that's like that scenario I gave you. It was a side, side, side. So I needed to find a missing angle. You have to go back to when we were doing inverse sine and inverse cosine in our calculator. And recall that when you press in your calculator second sine or inverse sine, that it only pulls from certain quadrants. Remember that inverse sine only found angles in these two quadrants. So did inverse tangent. But inverse cosine would find angles in these top two quadrants. So if you were to have a triangle that had an obtuse angle in it, it would be an angle over here in the second quadrant, something bigger than 90. And if I press in my calculator second sine, it's not going to give me that angle. So when finding the missing angle, remember that inverse sine will not find obtuse angles. So if you're given a side-side situation, like I did there earlier, you're going to use the law of cosines to find potential obtuse angles. Now, you don't have to use the law of cosines multiple times. You just have to find if there's going to be an obtuse angle, you're going to find that first. Now, if you're given another scenario where law of cosines is used, side angle side, you have to wait to find the potential obtuse angle by subtracting from 180 at the very end. All right, let's try both scenarios. Now, there's no guarantee that this is an obtuse triangle. They aren't all obtuse triangles. It's just that you have to be on the lookout in case it's an obtuse triangle. So this is that side, side, side scenario. I want to use my law of cosines to find a potential obtuse angle. Now, in college algebra, you never had to worry about this because we just purposefully didn't give you obtuse triangles because you hadn't learned that thing about the inverse sine yet until you took trig. Well, in this case, when I look at these three sides, whichever side is the longest is going to be across from any potential obtuse angle. So in this case, that means side C is the longest. So I would want to be doing inverse cosine on angle C. Well, if I'm going to do inverse cosine, that's going to be at the very end where it says cosine C. So that means I have to start my law of cosines with a C squared, which I don't know. I'm sorry, which I do know. So I'm going to use this version of the law of cosines because it's going to be cosine C, and that's what I'm going to find. All right, here we go. 18 squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of C. All right, now you start peeling away at this, and the big thing you don't want to do is do this subtraction here. You don't want to add these up and then subtract this because it's being multiplied right here, and this is tied together. So what we do first is we move these two guys over to the other side. So in my calculator, I'm going to do 18 squared minus 10 squared, or I could just write 100, would be fine too, minus 144, and see what we get. I got an 80. And then that's going to equal, so this is still there, and I'm going to go ahead and multiply that together. That's a negative 2 times a 120, so negative 240 cosine C. So let's divide by the negative 240. And I get a negative 0.3 repeating. It was a 1/3. But now I'm going to do second cosine on that answer. And I end up with angle C being 109.5. It was obtuse. So it's a good thing I went through that process to find angle C this way. All right, once you have one more piece of information, then you're just back to law of sines because you now have this matching set that you can use to set up your law of sines. And there will never be a second triangle on these problems. It's only on angle side that would ever happen. And I'll go ahead and just work with B. So I'll put 12 there. I'm going to find the sine of angle B. So in my calculator, I multiply the parts I know. So that's 12 times the sine of the 109.5, divide it by the 18, and then do second sine on that. All right, so angle B is a 38.9 degrees. And then I'm just going to subtract from 180 to get the missing angle. And so that means angle A, if you want to do 180 minus the 109.5, just since these are notes, or maybe since you've done law of sines, you're okay with this. But we get angle A to be 31.6 degrees. All right, this is how you do a scenario that is side, 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 like this. That's not the only time that we use the law of cosines. Here's another scenario where you might need to use your law of cosines, because you can see that I have given three things here, but I still don't have a matching set to set up my law of sines. And I can't just go find little a, I can't find another angle. So this is actually called side angle side, is what this scenario would be. And I'm kind of forced into using my law of cosines, and I don't really even have options because they only gave me one angle here. I'm going to have to finish this off with a cosine A. So without even having to decide what angle or what side would be obtuse, I don't have options. I have to go with a squared is equal to 7 squared plus 13 squared minus 2 times 7 times 13 times the cosine of 42. Now, this is kind of the easy one to do in your calculator because you have absolutely everything you need over here. So you just go straight to your calculator and just type it in left to right. So 7 squared plus 13 squared minus 2 times 7 times 13 times cosine 42. Never taking a break. Don't press enter. Just left to right. There it is. So a squared is 82.7. And then I'm going to square root that. And I have A is a 9.1. So now I have my three side lengths. I have A here, I have B, and I have C. I still don't really have options. I'm going to have to go ahead and go with my A's to set up my law of sines. So here we go, 9.1 over the sine of 42. But here's where I do have to make a decision. Because when I'm setting up my law of sines, I'm going to end up doing inverse sine to find the missing angle. And if I do that, I know it won't catch an obtuse angle. So what I have to do is I have to purposefully not be doing my obtuse angle here. So I can look at my side lengths and see that C is the longest side. So C would be obtuse if there was going to be an obtuse angle. So I'm going to purposefully not do that with my law of sines, and I'm going to do the B instead. All right, I'm in a hotel room. Can you hear the sirens going? Okay. All right. I'm going to do a 7 over the sine of B. Okay, so in my calculator, 7 times the sine of 42 divided by 9.1, and then second sine on that. All right, so angle B is 30. Actually, it's 31.0 is what that would round to. Got it. Okay, got it, got it. Okay, so now the last thing I need is angle C. And I'm going to find that just by doing 180 minus the other two. Now, see how I'm going to do this? 180 minus 31 minus 42. And I get angle C to be 107. And it is obtuse. But I didn't have to worry about finding it through the law of sines because inverse sine won't find it. So if this is the scenario, then you have to wait until the very, very end and just find that potential obtuse angle through subtraction. All right, so those are your two scenarios. And I'm not going to do a ton of examples. I think they're pretty straightforward. Those are your two types of problems. But we do have a couple other things. We have a pretty slick area formula for a triangle. It's called Heron's formula, and we know the area formula 1/2 base times height. Known that since the 5th grade or something. So this is a formula that I think is probably more helpful when you're finding the area of a triangle if you know all three side lengths. And you may have learned this in college algebra, or maybe not. Sometimes we do it, sometimes we don't. But just it's a very straightforward formula. If you know all three side lengths, you would just take your perimeter and divide it by 2. So take half your perimeter, and we call that S. And so that S measurement is just stuck into this formula. So you'll take that half perimeter, and then you'll take it and subtract each side and multiply those together, square root it, boom, you got the area. Now, the only thing is that you have to have no side, side, side. So you may have to use your laws to get all the sides figured out first, and then you can go do your formula. All right, so here's one. Here's 3 side lengths. So the first thing I'm going to do is I'm going to find my perimeter. And so the perimeter would end up being 21. So S is half of that. S is 10.5. Now, run it through Heron's formula. Area will be big square root. You take that S value, that 10.5, and then you're going to take 10.5 minus 7. So that's 3.5. Take 10.5 minus 4. That's 6.5. And 10.5 minus 10. That's 0.5. And then we're just going to type it in the calculator. Easy peasy. All right, and our area ends up being 10.9. And this is the units squared since you're doing area. All right, now I do have one other thing I want to talk about. And that is where you see the law of sines and the cosines on the ACT. Now, this is usually higher level questions, but you guys are the ones that are going to be doing these. You're the pre-calc kids that are trying to get those 30s on the ACT. And so you need to be able to get these types of problems correct. And now that you know your law of sines and cosines, I'm going to say that in general, the actual problem is not that complex typically. And it's just a matter of, do you know what you're looking at? Okay, so in this scenario, I just picked some. Here's one, and they give you the picture. They have all kinds of reading up here, but the picture has all of it in there. And all you're looking for is the length of BC. So when you look at this, how would you set this up? Notice here, they don't really ever compute it. The ACT supposedly can be done without a calculator. So they won't ever actually have you compute it. You just have to be able to set it up. So looking at this, you have to decide, is it a law of sines or cosines? Well, I have a matching set right here, so I know it's law of sines. But since I'm looking for this side, I would need to know that angle up there. So I would do a quick 180 and subtract the 34 and the 41 and find out that it's a 105. So right off the bat there, I know this is 105. So let's set up our law of sines. It would be 25 over the sine of 34 equals little a, which is what we're searching for, over the sine of 105. Now, they still didn't write it quite like that. What they're doing then is they're saying, okay, well, how would you solve that? Well, I would take the 25 times the sine of 105, and then I would divide by the sine of 34. So if you find that one, looks like it's option B right here. All right, on this example, they're giving you a triangle with all of the side lengths. And the question says, which of the following expressions gives the measure of the largest angle of the triangle? Okay, so you need to know, well, the largest angle would have to be across from the largest side. So that would be this angle right here. You're not going to go find all the angles and then see which one is the biggest. You're just going to go find this angle because I know that that would be the largest one. So then knowing that, I'm looking for that angle, I know that I would end up at the end saying that angle. So I don't know, I guess I'm going to call it X because they didn't label this. So I know that it's going to be 39 squared equals 38 squared plus 37 squared. And again, they didn't really compute this. So it's just a matter of me figuring out how would I do this? Well, I would take my 39 squared and I'd subtract the 38 squared, subtract the 37 squared. That is not what happened here. It did happen on this one. It did not happen here or here, but it did on this one. Okay, so now the next step after I would do that is I would be dividing by, oops, not there. Let me undo that. This is being multiplied right here. So then what I would do is I would divide by this, -2 times 38 times 36. Wait, sorry, where did I get a 36? I was talking earlier while I was writing, thinking I was being efficient, but I was just confusing myself here. Those are 37s. Okay, so it looks like it's the scenario right here of law of science, not the version where you know everything. So I'd go with B on this. All right, last one. This is a little bit more challenging than the others, I feel like. Just the picture itself seems a lot more going on. And again, they give me all of this in the reading, and yet they fill it on the picture. So just trying to be efficient, like, let's just see what they want. Which of the following is an expression for the straight line distance between the two ships? Okay, so ship A and ship B, I'm looking for the question mark. Surprise, surprise. Okay, now what I'm going to do then is I'm going to look at this triangle here, I guess. It's nice when you start seeing these as your options and you're saying, oh, this is one of those law of sines and cosines. I mean, just by looking at what the answers are should help you determine, oh, this is the law of sines or cosines. All right, so let's see what we're looking for. I know I have two sides, the 20 and the 30, looking for the third. So I'm going to need to know this angle up here to work through this. Let's see if we can figure that out. It says that it's 300 all the way around here, and it's 270 just to here. So really the angle I need is the difference between the 300 and I might have said 270, it's 170. The difference between the 300 and the 170. Well, what is 300 minus 170? Well, that's pretty straightforward. That's going to be a 130. So now I know I'm going to be using an angle of 130. And if you glance at your options, well, there's only one that says the cosine of 130. If I'm really pressed for time, I'd probably, if nothing else, make a good guess that that's what it is, right? Otherwise, you could just run it through. It's going to be x squared equals 30 squared plus 20 squared is 2. And lo and behold, yeah, it is that version. And then you just end up square rooting both sides to get to your leg. So it's B. So once you know what you're looking for on those problems, they really aren't all that tough on the ACT. All right, very last thing. Oh, this didn't come across very good, does that? I have to redraw this a little bit. This is called the triangle inequality theorem. That's what this word is. It probably looks good in your notes. It just isn't looking great for me. Okay, so the triangle inequality theorem comes from geometry, and it's the thing that says that two legs of a triangle have to add up to be longer than the third side for the triangle to even be created. Something like this. If I had a 7 here, and let's say this was 4, but this leg was only 2, that's not long enough to actually create the triangle. Even as this leg kind of comes down and comes down and comes down and comes down, it's going to hit right here. 2 is going to come hit here. They're never going to touch. So you have to make sure, that's just one more thing that might get thrown in the mix here, is that if they give you three sides, you got to make sure that two of the sides will add up to be longer than the third side. Otherwise, you might just end up without having a triangle at all. All right, that's all I've got for us on law of cosines. Have a great day.